Hello, welcome back to this physics video student. In today's video, I'm going to discuss over here block and tackle system, or either that it was also known as combination of pulley. Okay, so in our previous topic, student, that we were having the discussion that was regarding to single fixed pulley, single movable pulley. Okay, now over here we are taking that it is combination of the pulley, which is also known to be as block and tackle system. Okay, so block is what? So already that definition we did over there. Block is what? It is that structure which holds or in which this pulley is placed. Okay, so over here you will find that there is this rectangular piece which I have shown over here in this diagram. So this is what? This is that block. Okay, so here is that block, this is block. Okay, so and these pulleys, they can easily rotate on their axis. So here these pulleys can easily rotate on their axis. Okay, now over here student, if you will see that there are the two block. Okay, you will find over here there is one block which is fixed with the this rigid support, and second block it is attached with the load. Okay, so there are the two block. So this block which is with the rigid support, which cannot move up and down. Okay, so that block it is said to be upper block. Okay, or either it is said to be fixed block. Why it is said as fixed block? Because it cannot go up and down with the load. Okay, it is fixed with the support, therefore it is that upper block or either fixed block. What there this lower block student, yeah, this lower block you will find that it is connected with the load. Okay, so in this lower block you will find there are the two pulleys. So therefore this block is attached with the load and it can move up and down with this load. Okay, therefore this block can have the movement up and down, and this is as lower block, or either it is said to be as movable block. Okay, so thus we come to know over here regarding to the block that there are the two block. One it is said to be upper block and the second it is said to be lower block. So this upper block which is fixed with the rigid support, which cannot move up and down, it is fixed block, while that block which can move up and down along with load, it is said to be movable block, or that lower block. Now you will find one more thing student, that always in the upper block the number of pulley will be greater than that of lower block, or either it will be equal. What I am saying over here, that the number of pulleys in upper block will be greater than or equal to lower block. Okay, so there can be only the two situation, that upper block can have same number of pulley as in lower block, or either it will have greater than, but never it will have less than lower block. Okay, so here you will observe that there are the three pulley in the upper block and two pulleys in the lower block. Okay, so maximum pulley that in lower block it should be three, but it should not be four in the lower block. Okay, so therefore you should to note this one, that the number of pulleys in upper block must be equal or greater than the lower block. Now we are going to bind the rope around it, so that is said to be as tackle. Okay, up to the time you have just seen that these are pulleys which are placed in the block. Okay, but rope is not used over here. Now what we are going to do, we are going to bind rope around the pulley. Okay, so therefore this is said to be tackle, and therefore what is this now? It is block and tackle system. Okay, now student, that you should to remember uh, this free end, keep the free end of this rope in your hand. Okay, this is the free end of the rope and pass it from the uppermost. Okay, and then you have to cover all the pulleys. Okay, so bring into the last in this block and tackle system over here. Thereafter take it once again into the second last, which is in the upper block. Now once again after covering it, bring it to the lowest block, and when it will cover it, so take it once again to the upper block, and Thereafter, when it will cover this upper block pulley, so bring it down. And here these are the two T, these are the two hangers shown with the block. Okay, so then if you will not attach this rope at this end, so you will find that this upper block and lower block, so they are not connected together. Okay, this lower block will fall down. Okay, so therefore this last edge of this rope, you need to tie it with this hanger. Okay, now whenever you will apply the effort at this end, so now the whole pulleys will rotate on their axle. Okay, and thus this load can be lifted up. Okay, so student, over here what we are doing, we are going to apply the effort once again. How to make the tackle? So you need to bind this rope around the all pulleys which we have used. Okay, so from where you can start. So this free end, you need to pass it from the uppermost of this fixed block, and then it will come to the last of this lower block, and once again it will go up, then to the lower block, once again to the upper, and thereafter to this hanger of the lower block. Okay, now to which side the tension will develop, because this rope will exert the force on load. Okay, so to which side these rope will try to lift it up, so it will be in the upward. Okay, so therefore upward direction in every segment of the rope, you will show this that arrow in upward. Here it is upward. So what is that one? It is the force. Now all segment of the segment, why I'm saying, just to look over here, this is the part of the rope. Okay, so it is segment. Here it is another part of the rope, it is another segment. It is over here to the right side, this is the one part of the rope. Okay, here it is another part of the rope, this is the another part of the rope. Okay, so these are the different segment which we are having. Here it is that segment. So therefore tension is developed in all segment. You have to show only a single arrow in every segment. Okay, now that arrow direction will be in the upward. So do one more thing, student, over here, that in every that segment, whatever tension you are going to show, that is same. It is T over here, T segment, that T tension will be developed in this one, T is here, T is developed in this one, and T is developed over here. Okay, so in every segment there is same tensional force. Why there is same? Because we have used only a single rope. So therefore same force will develop on every segment of this rope. Okay, so now let us to check over here, student, then what will be its mechanical advantage. Okay, so as we are known that how do we write this mechanical advantage? So mechanical advantage is given by and that of load to the effort. Okay, now you need to look over here that how many these tensions in the rope that is going to support this load. Okay, so you will find that one is this one, that one tension is this, second tension is this, third tension is this, fourth tension is this, fifth tension is this. Okay, so there are the five tension which is going to that balance the load, and this tension is going to balance that effort. So you need not to include over here this one. Okay, so thus I'm having that this load, it is balanced by the five tension which is developed in the that string. Now this effort which you have applied, so this effort you have applied only equal to this tension. Okay, so it is only equal to T. So now therefore I will put it in this relation, and it is given by that of 5. Okay, so how much is that mechanical advantage? It is 5. Okay, one more that thing which you can observe, how many pulleys do we have? 1 2 3 4 5. Okay, how much is the mechanical advantage? It is 5. Okay, so thus we can say that this mechanical advantage, it is equal to number of pulleys in block and tackle system. Block and tackle system. Okay, and there is one more thing that you can check that how many that segment of the rope is going to balance the load. It is 1 2 3 4 5. Okay, So how much is the mechanical advantage? 5. How much is the segment of that rope which is balancing? It is 5. So we can also write it as, or mechanical advantage equals equal to that of number of that segment of that rope holding the load. Okay, so that's we are having over here. These are the different ways by which you can calculate this mechanical advantage. Okay, now it's time to find out this that velocity ratio, student. Okay, so how we will find this velocity ratio? So velocity ratio, how it is given? It is given by that displacement of effort to that displacement of load. So just to look in this diagram, student, if I'm supposing that this load is going up, okay, so how much is that upward movement? It is d. Okay, so you will find that this side of the rope, how much it will move up? It will move up by that d. And how much is every segment will move? It is d, every segment will move. Okay, so if every segment of the rope will increase, that will move by t, so therefore this finally effort, how much it will come down. Okay, so how much is the displacement over here? So it will be how many segment of the rope over there? It was 5, and therefore that displacement, it will be 5 times of that d. Okay, so thus I get over here that it is this is going to be 5d. And velocity ratio, therefore it will be 5d upon my d, and it is 5. Okay, so thus I have over here velocity ratio 5. But now, student, one thing remember over here, this mechanical advantage will be equal to number of pulley in the block only in that case when we have this ideal pulley system. When we have ideal pulley system, then we will have over there, this is mechanical advantage equal to number of pulleys in the block. Okay, but if that machine, this pulley system, it is not having that weightless pulleys. Okay, so therefore and there what will happen, we have to do more effort because the load of the pulleys will also be included in it. Okay, therefore this mechanical advantage will not be 5. Okay, so that, student, we should to look over here that if weight of pulley included, then mechanical advantage will not equal to velocity ratio. That implies mechanical advantage will be lesser than that of velocity ratio. Why it is lesser? Because mechanical depends on that load. Okay, so therefore it is going to decrease. Okay, so when it is going to happen, when we do not have this is as ideal. Ideal mean to say in which there is perfectly weightless pulleys used. Okay, so therefore we are getting, and this is efficiency. Efficiency is what? So it is given by mechanical advantage to that velocity ratio. And percentage of efficiency, if we have to calculate percentage, then it will be multiplied by 100. Okay, so if it is ideal, then it is 100%, but we are known over there that we can't have any pulley which is weightless or any rope which is weightless. So therefore this will not be 100%. Okay, but one more thing, that why we are using this combination of the pulley. So you are looking that mechanical advantage is greater than 1. Okay, it is greater than 1, so it is generally used for this force multiplication. Okay, so thus, student, this is all from my today's video. Thank you for watching.